students. Now, today in continuation with the topic electric flux. Already in earlier video I have explained you that electric flux is EA cos theta or ES cos theta, where E is electric field intensity and S is area vector. Okay, it means phi is written as E dot A or E dot S. But sometimes if you see that, say there is a area, it is given delta S, small area, and the lines are going like this. Electric field lines are going like this. So, if I see this, the electric field is in this direction and the area is in this direction. Then this vector is delta S vector. So, this is the angle. Even we can write delta phi equal to what? E dot delta S. So, for a small area, we have small electric flux. So, delta phi, or we say d phi, is what? E dot ds. So, this flux can be written in this way also. And SI unit of flux, yesterday it was discussed in my earlier video that it is ES, so Newton per Coulomb meter square. Another SI unit for it is volt meter also. So both are the SI unit. You can write volt meter also. Now I have two simple questions for this, for electric flux, which I can discuss with you. Say if electric field is given in some region, if E is equal to 6I plus 3J plus 4K, you know the electric field vector quantity, and we want to calculate the flux. So say calculate the flux, the electric flux through a surface area of 20 units, okay, in some plane. Say it is YZ plane or XZ plane. Now YZ plane, XZ plane. So it's a YZ plane. Now if I ask you, say this is X, this is Y, this is Z, this is YZ plane. Got it or not? Now if you see this YZ plane, where is the area vector? It is in this direction. Okay, this is the area vector, perpendicular to it. And the electric field is what? 6I plus 3J plus 4K. So, what is area? So, what will be S? I think all of you know 20 what? I. Because it's I, it's J, it's K. So, this will be, what will be phi? E dot S. So, do the dot product. You know, you have gone through it in class 11th. Very simple. Dot product dot 20I. So, I think 6 into 20. Directly you get answer 120 watt units. So, 120 units is the answer. Rest J dot I 0, K dot I. So, directly 6 into 20, I dot I is 1. So, this is very simple numerical. So, how you calculate the electric flux through any surface. Now, another question I can give you here only. Say, there is a cylinder given like this. Okay. And the electric field is being represented in this direction. So, the question will be 1 mark. Find electric flux through cylinder. Okay. So, if I draw it, You see in the cylinder, this is the electric field. Okay, where is the area vector for this? In this direction. Say you say it is delta S, and where is the area vector? Say it will be in this direction. Why in this direction? Because area vector is always outward. And if I want to take here also some small area, where is the area vector? This direction. Where is the electric field? In this direction. So this is 0. Why? Because angle is 90 degree. So for this surface, flux will be what? E delta S cos 0. Why E and delta S are in the same direction? So E delta S. This is phi 1. For this will be what? E delta S cos 180. What it? Minus E delta S. Why? Because here angle is 180 degree. Electric field is in this direction, area vector. Here angle is 0 degree. Here angle is 90 degree. So flux for here it will be 0. Because cos 90. So add them. The net flux will be 0. E delta S minus E delta S. Okay. It makes it what? 0. So you see that why? Because the same number of lines are entering from here and same number of lines are moving out. So net flux is 0. So this is how we calculate the electric flux. I have given you two simple examples that electric flux is E dot S. Now we'll talk about the electric dipole. So what is electric dipole? First, have you heard about the dipole? Dipole means two poles. Okay. And in chemistry, also you have heard about the dipole. But in physics, what is electric dipole? Okay, in chemistry, have you heard about the H2O molecule? So we know that dipole. Okay. How this is a dipole. But in physics, we know that if we have two charges, say one is minus q and one is plus q, and they are separated by small distance, it forms a dipole. Okay, the magnitude is same. One is plus, one is minus. So how you define an electric dipole? An electric dipole is a system. You can write it. An electric dipole is a system of two equal and opposite charges separated by a small distance. Remember, this distance is very small, this one, and say this distance is 2a, this is the center. So what is O? If I ask you, it is the center of the dipole. O is center of dipole. 2a is length of dipole. Even we can say A also, but 2a is the length of dipole. A in this side, A in this side from the center. Length of dipole. And another very interesting thing is that if I ask you what is net charge, 1 mark question can come in the board exam. Net charge in dipole. Okay. So net charge is what? Do you know? 0. So if I ask you what is net charge on dipole is what? 0. And then because it is system of equal and opposite charge, plus q minus q, they will create a field also later on. So there's a word dipole moment. If I ask you, have you heard about the dipole moment? I think you have heard it in chemistry also, but here is also a word electric dipole moment. So dipole is a formation of a system of two equal and opposite charges And what is dipole moment? If I ask you, this is minus q, this is plus q, which is forming a dipole, this is center, this is say 2a. Now there is a word dipole moment, and dipole moment is a vector quantity. What is a dipole moment? It is the product of either charge and the distance between the two charges. Simple. Distance between the two charges. So if I ask you how you are going to define a dipole moment, P is Q into 2A, and it's a vector quantity. So P is Q into 2A. And what is the SI unit? SI unit will be what? Coulomb meter. Q for coulomb, and 2A is the length coulomb. So dipole moment is simply Q into 2A, and direction is from minus to plus. So minus Q to plus Q is the direction of the dipole moment. So this P is electric dipole moment, and direction from what? Minus Q to what? Plus Q. This is what how we are going to define dipole moment. And now if you see, we can even calculate the dipole moment for the charges also. Say there is a system, I'm going to give you a simple question. Say there is a question comes in the paper that there are two charges of 3 microcoulomb and minus 3 microcoulomb given, okay, and separated by say 2 centimeter. Find one is net charge on dipole and second is dipole moment. Okay, so if I ask you this, very simple, I think you got it. This is minus 3 microcoulomb and this is plus 3 microcoulomb, and this is the center. The total distance is 2 centimeter. What is the net charge? Now tell me, what is the net charge? If you see, net charge is always 0 in a dipole. Minus 3 microcoulomb plus 3 microcoulomb, it makes it 0. And what is the dipole moment? Q into 2A. Now Q is either of the charge, 3 microcoulomb. Micro means 10 to the power minus 6. Length is 2 centimeter. 2 into 10 to the power minus 2. So 3 to the 6. 6 into 10 to the power minus 8 coulomb meter. So this will be the dipole moment and the strength of the dipole, how we are going to calculate it. So this is very simple question, that how we calculate a dipole moment. And now what happens if any dipole is placed in a uniform electric field? So there's first derivation based on this. Torque on an electric dipole in a uniform electric field. Remember, uniform electric field, equidistant parallel lines. So you can calculate the torque on the uniform electric field. What is that? Very simple. When you are going to calculate it, say the electric field lines are given like this. So these are the electric field lines. This is a uniform, and any torque when it is produced by this line is on the dipole. Dipole is given like this. Now this is plus Q, this is minus Q, this is the center of the dipole. And do you know, on this, because this is the direction of electric field, this charge will get a force on this direction. You remember QE. So QE will act on this direction and minus QE will act on this direction. Remember electrostatic force QE. and this is the length of the dipole. Got it? So how you have drawn electric field intensity, dipole, length of dipole, center plus Q will take it in this direction. So it will rotate like this. And this is an angle, say theta. So theta is the angle between them. And then we draw a perpendicular from here and just join it. It's a 90 degree. And this is 2a. So this is theta. This will be also theta. Why? Because corresponding angle. And this length will be 2a sine theta. So how we calculate torque? So torque, I think all of you know, is the either force into perpendicular distance. In 11th you have gone it through this topic, torque. And torque, either force is what? QE. What is perpendicular distance? This one, 2a sine theta. So torque will be Q into 2a E sine theta. Now can you tell me what is Q2a? Q2a is what? P. अभी we have discussed, अभी करा हमने PE sine theta. We know that P is Q into 2a. So torque is PE sine theta. That means torque can also be written as, you know that sine product, cross product, P cross E. So this is torque. This is the derivation which is given in the paper also. How you find out the torque? Torque, remember, it is P cross E. Cross product. It will rotate like this. And one thing is that net charge on dipole, already explained, net charge on dipole is what? Is 0. Already we have discussed this. Can you tell me what is the net force here? Net electric force. It is again 0. Why? Minus QE plus QE makes it what? 0. So these two things we have to remember. One is the net charge, one is the net electric force. Torque is P cross E. And if you remember what was cross product, the cross product means that torque is perpendicular to P and torque is perpendicular to E. So this is how we calculate torque P cross E. And in this way we can find out the questions based on the torque also. And I will give you a simple question how to calculate. You got it? This is 2 mark derivation. Torque is P sine theta. So we can even do some numerical based on this. Say a question is given, dipole of system of 2 charges. Okay, 2 charges plus 2 microcoulomb and minus 2 microcoulomb separated by say 4 centimeter and placed at 60 degree with electric field. Electric field is given say 10 Newton per coulomb. Then find what 2 things. First, dipole moment, and second is torque. So how we are going to find it? Dipole moment is P Q into 2A. You will find out P Q into 2A. So what is Q? 2 microcoulomb, and length is 4 centimeter. So into 4 centimeter. So it makes it 8 into 10 to the power minus 8 coulomb meter. This is dipole moment. I think you got it. Earlier we have done it. Now what is torque? Torque is P sine theta. What is P? Q into 2A. E given sine theta, sine 60. Okay. So Q into 2A already you have calculated. We can write 8 into 10 to the power minus 8. What is electric field? 10. And sine 60, all of you know it is what? Root 3 by 2. So 2 5 is 10. It makes 40 root 3 into 10 to the power minus 8. Can you tell me what is the unit of torque? It is Newton meter. So 8 5 is 40 into 10. So this is how we can calculate dipole moment, and we can calculate torque. Very simple. It is given in this. So this is the topic we have discussed right now. Later on we'll talk about the electric field intensity due to dipole. And thank you, regular watch these videos.